Hello and welcome. My name is Merel Bout. I'm an R&D scientist from the Netherlands, and I work at a company called Tiofarma, which is a contract manufacturer for many small molecules. And one of these molecules that we're going to talk about today is called enalapril maleate in combination with an excipient, sodium starch glycolate. And we've performed an incompatibility study between these two to find out what was the mechanism behind the interaction that was observed. So what entailed this observation? Well, I have the two pure substances right here. And as you can see, they're regular free-flowing powders, and they're very stable on their own. So it makes it most unfortunate that once we've mixed the two together, as you can see, it's physically altered. But most importantly, EM became fully inactive. It degraded into a cyclization product called DKP. So we decided to make this interaction our study. And we've looked at the influences of the contact surface between the particles and the influence of moisture. And since we looked at the result of the chemical and physical stability of our API, we had to use complementary techniques since not one technique was sufficient enough. And what were the outcomes? One of the outcomes was that there was a decrease in the crystalline structure of EM. And that can be displayed by the morphology results beautifully. As you can see, in a dry environment, the red crystals of EM and the green particles of SSG remain unaltered. And only if in the presence of SSG and in a humid environment, we saw that there was a physical transition or a loss or disappearance of the crystalline content of EM. And this can be put in a scheme as well. So only the bottom one led to a physical transition. And we also observed that chemical degradation was only followed after this physical transition. And as we know, there's not enough moisture present to dissolve this crystal, and it was before full degradation took place, there must be some kind of new amorphous structure of EM forming. And with that knowledge, we postulated that the increased mobility must be initiated by moisture coming from the excipient SSG. So we influenced the moisture content of SSG, which can be seen here. And we saw that with more moisture content added to the excipient, which can be seen here, more degradation of EM occurred. And as most of the time, so overall, moisture, water, and pH almost always go hand in hand. We also looked at the pH of the mixtures and looked at the influence of pH. And we know that EM is able, theoretically, to obtain 4 different protonation states. And one of these states is the zwitterion, which is displayed here. And the zwitterion is a state where there's a positive and a negative group in the molecule. And this state is thus very likely to form the cyclization product DKP, as it has 2 opposite charges that are magnetically attracted to each other. And which can also be seen in the graph here is the teal color is this zwitterion and the protonation states. And we can see that in a range between 2 and 6, the zwitterion is present, and it's mostly present between a pH around 4.5 to 5. And we looked at the theory and we put it into practice by increasing the pH of EM powders. And we also saw that with an increasing pH, more degradation took place. And we traced that back to the presence of the zwitterion. So in short, what did we find? Well, we saw a phase transition and formation of a zwitterion. And we saw that the physical change, the physical transition, was not only with our eyes visible, but also with our techniques. And it's because the crystalline structure of EM is disappearing. And this transition is dependent on the moisture content of SSG, which can be seen here. And only after a closer look at the contact between the particles that there is a little fraction of the crystalline structure that gains mobility, and the structure no longer fits in the crystalline lattice, and it cuts the rigid stable bonds of the crystal, introducing a new amorphous structure. And only a small fraction is also able to dissolve, and dependent on the reigning pH of that layer between the particles, the zwitterion is formed, which can form DKP, and the equilibrium goes to the right. So, therefore, moisture can be detrimental when in the wrong hands, And in the case, it was the excipient SSG. And we saw that by removing the moisture, no degradation took place and the interaction was inhibited. So thank you very much for your attention. If you have any questions, please let me know. I'd love to talk to you virtually. Bye!